Hello and welcome to our podcast. This is Neil Strange, and I'm today joined by Alex Higgs.
Hello.
Just wanted to ask you a few questions today. I mean, we've been talking a lot in the office about semi-structured data and so on, and things like JSON and XML, and we're seeing an awful lot more of these nowadays in our work. Tell me, what are you seeing? Why do you think we're seeing this?
Yeah, so I think, data has always been exchanged in some kind of semi-structured or structured way. JSON has always been popular. XML among developers has been less popular, but has been usually by the data providers been a lot more popular. I think the reason we're seeing it a lot more and a lot more people are talking about it is because the tooling's catching up to being able to process it inside the data platform a lot better and a lot more easily in more recent years. So with the advent of the variant data type in Snowflake, for example, and similar capabilities in other platforms, it's becoming a lot easier to process it in line, as it were, rather than having to pre-process it all before it even gets to the data warehouse.
Okay. I mean, do you think it's got something to do with the fact that most source systems nowadays, with the architectures that are coming out, they tend to build APIs in?
Yes.
APIs send back a packet of data when you request it.
Exactly.
Yeah.
And I still think we're seeing the kind of aftershocks of the micro service craze as well, with lots of microservices around generating JSON everywhere.
Okay. So I'm sitting in a warehouse. I want to go and fetch back some customer data. So I poke an API and say, give me all the customer data, give me everything that's changed since a certain date, some sort of filter in there, and I get back this blob of JSON in there, which could be one customer record or thousands of customer records, all buried in a. It's not really a file, is it? It's more like a stream coming out.
Can be, yeah. It depends on the source system.
Okay. So fine. So you get this data arriving. So what can we do with that data? I mean, if you're working with big data, for example, you shouldn't be processing that data as much as possible. So the question I'm always asked by people is, should I split that up into its lowest components and load that into a regular table? Or should I keep the record together and load it as a variant?
Yeah.
And to what level do I break that record down? You know, if I've got 1,000 customers in there, do I retain all 1,000 in the file and put it on the side?
Yeah.
And go fish the data out when I need it, or do I break it into the 1,000 individual records?
It's a very good question. I think that the answer is always going to be it depends.
Mm-hmm.
I think we lean generally towards split it up and process it as little as possible early on and do as much as you can later on.
Mm-hmm.
So extract late, perform business logic and business rules on it in the business vault in a data vault context, and in your silver and gold layer in medallion and things like that. Yeah.
Well, I guess it also depends how often you query it downstream. So if I'm going to query it 20 times a day, it's best to have it split once rather than having to split it 20 times each time it's queried.
If it's data you're not using that much, leave it as a JSON blob. Get the end user to extract it or create a view specifically for them with the bits they need extracted rather than extracting it early and adding complexity. Yeah.
Now, I mean, if you look at this problem for a little while, I mean, immediately you get this sort of aha moment where you say, well, what happens with slowly changing schemas? So, you get a feed from a well-known CRM package maybe, and the end users decide to create a few extra columns in a table, and before you know it, you've got this different data schema arriving.
Schema drift.
Now you should be able to, of course, that shouldn't be allowed because of governance, strict governance, but let's say this happens. JSON gives you a way of sort of wrapping protection around that by just storing the JSON string as it arrives, as opposed to having to have a table created with a column for every value and suddenly finding there's another 2 columns added or a column's missing or something from the format.
Yeah, exactly. It's a big blob of JSON. You don't necessarily care what's in it until it comes to extraction time. So that can create a bit of a more robust ingestion system. And if you have something like a JSON schema, so there's lots of ways to validate JSON. If you have a known and version schema of that JSON of what keys you expect and what data types they expect to be, there are checks you can do on that. And this obviously leaves inevitably to data contracts.
Oh, yeah. Okay. So it depends where you apply that contract. I guess you could apply that before you load the JSON in, or you could load the JSON in and then validated afterwards before feeding it down to
Exactly.
a downstream system.
It depends the use case for that data. If it's feeding, the CEO's dashboard, you might want to be a bit more careful about how you handle it.
Okay, so let's just talk this through. So I query an API and I say, tell me about the customers, or probably even more likely, I would say, tell me about the customers and the orders that they've placed. So I want a linked set of data to be sent back to me. I don't want to keep querying for each type of thing. Give me customers, give me invoices. I want them as one API call.
Mm-hmm.
So I get back this more complicated JSON structure. I've got all the customers in there, the orders that they've placed, the products that are in the order.
All these relationships. Yeah.
All those relationships done through a sort of nested hierarchy of things in there. My view on the processing on that is you'd land that and then you do some pre-processing. So you break it out into the individual objects, because you've got to target a data warehouse in the end where you'll have areas to store customers and products and invoices separately. Yeah. So you're going to split it up by those, then probably split it up by individual customers and products and orders.
Yep. Yep.
And then you insert that into your data warehouse where you have a JSON packet of data that describes the particular customer inside the customer area, particular product, a particular invoice.
Mm-hmm.
But you do no further. You break it out no further than that.
Yeah, I think that's a good way to do it. It's like I was saying earlier, it is extract and process late. Mm-hmm. So only extract and flatten is usually the term we use. What you need in order to be able to process those concepts downstream, and leave it like that.
Okay. Now, if you're loading a data vault, mm-hmm. and probably the same thing goes for other data warehouses as well, like Delta Lakes, you only want to load data when it changes. Okay. But if you look at that JSON object that's arrived, you've probably got some columns in there which are metadata that change, like the date of extract, for example.
Yeah,
the payload might not change, but you're running this extract daily or hourly. Bring the data across, so that date timestamp's going to change. So you want to work out if there's been a change in the JSON object, but you want to ignore certain components of that to be able to do that.
Oh, you have a very complicated hash diff.
How would I do that?
Yeah, I mean, so in an ideal world, a lot of this metadata would be under its own section in the JSON, or they would be the top level keys. So quite often you see some top level keys for all the shared keys for that data, and then you might have a results key that just has a list of all the records in, which is perfect for the data engineer. I'm happy when I see that, because I can just extract it, and if I've got all the rows individually, great. But sometimes it might be a bit more nested and a bit more messy. At which point you might want to do some analysis and make sure you understand which columns are constant and metadata, and just have a preset list of columns that are treated as metadata and only extract those.
Right. The other thing I think about also in JSON is that isn't the ordering of tags unimportant, because they're all named. So
yes,
it's
just key values.
On each query you get back, you get a slightly different ordering in the tags, and therefore if you do a hash diff on something to work out a checksum, you're going to have a different value even though the content hasn't changed.
Yeah, there are some platforms that deal with that nicely, but don't rely on it.
So how do you get around that?
Well, again, if you are having that issue, you could probably restructure the JSON slightly at source in an ideal situation, but you don't always have the
So what, like an alpha sort on the tags or something? Is that possible? Or?
Yeah, I mean, I don't think you necessarily need to do it with JSON. However, if you do have that issue, you want to restructure it into a known structure before you start processing it.
Okay.
Something that you can rely on being the same.
Okay, so then essentially what you're doing then is when you're loading it into the warehouse, you'd be taking out the primary key, other metadata, storing those in known columns.
Yep.
And then just one variant where you put the JSON object, and that's it. Boom, in it goes, and you worry about the schema drift later on downstream.
Exactly. I mean, it's very similar to how a satellite works in Dataport, actually, where you've got the payload of all your descriptive columns, which is essentially the variant, and then you've got your metadata, which is the primary key, and the hash diff and the load data in the record source.
Okay.
Yeah.
So one other question then is, in there, as I understand it, JSON has a much more limited range of data types than your typical database.
Yeah.
So how do you cope with that?
Yeah, I mean, speaking to the engineers out there, we've all seen someone mangle a data type that's not supported into a string and then having to be reprocessed later. It's awful. So this is where things like a JSON schema come in. So you know that X column should be an integer, and then that can be processed as a business rule or as a soft rule downstream, or depending on what you need to do with it, it might be a staging rule that you put in.
How about nulls, for example?
Yeah, well, yeah, the biggest issue I've seen with JSON handling is not converting an empty string to null, or handling it as an empty string when it's supposed to mean nothing, and that can be a world of pain. Sometimes you want an empty string, most of the time you don't. And at that point, it's a data quality issue, I think.
Okay, so in one sense, it helps a lot, but you've got to have your brain switched on, your wits about you when you're processing this, to keep your eye open for data combinations.
Exactly. With these things, it's a case by case basis, and I can't give a blanket answer for everything. It depends on your data or your organization. But as long as you have careful consideration of how to handle an empty string, how to handle a null, and you make sure the rest of your team understand how to deal with that, that's the best approach, I think.
Okay, so the only other thing I can think of in this is that you have sometimes you have lower level data elements in there. So a good example is you might have a customer address, but they've got three logical addresses that they can have, or 5 or 10. It doesn't matter. The JSON just extends out to cover all the addresses we know for that particular person.
Yep.
In a relational database, you'd have to create an address table to store those in. Yeah. Or in a data vault, you would probably create a multi-active satellite with addresses in, or you create a locator concept, which you would then link the individual to say, yep, they make use of this locator.
Lots of different approaches. Yeah.
Lots of different approaches, some pluses or minuses for those. But I guess you could, with JSON now, you could actually store that all in one column, because you'd hold the substructure in the JSON elements. It was all stuck in the one column, and you'd fish that out later on when you wanted to have process the logic around it.
Exactly, yeah. It allows for some quite nice, I wouldn't say hacks, but you can avoid complexity quite easily by doing things like that. Yeah, I think the main thing to consider with all of this is when you're extracting, is make sure that data extracted, that the data that you have extracted is traceable back to its source file. So make sure you extract it along with a file name and a date time. So you can say...
So your record source will be the file name and the date of extraction, sort of concatenated. So yeah, that makes sense.
Don't lose track of where it came from. Yeah, otherwise, pain.
Okay. All right. I think that sounds interesting. So have we built anything on that respect in terms of this for clients?
Yeah, I mean, I've done quite a lot with JSON now. I've built all kinds of things to generically extract different JSON structures, splitting it up differently, creating different satellites for different parts of the JSON in the data vault context. Like I say, the great thing about right now in the industry is there's lots more tooling, lots more capability for handling unstructured data, and it's pretty much the sky's the limit. Think about what the ideal situation is, and you can probably implement it.
Okay, so you can mix the older techniques with the new and progress, push ahead with your life.
It's the best time to do unstructured data stuff.
Fantastic.
Semi-structured, I should say.
All right, well, I think that's enough for today. Thank you very much for talking. It's been Neil Strange and Alex Higgs here, and we'll see you all next time. Check the links out in the panel on the side, and do join our user group. Thank you.
Yeah, thanks very much.
Bye-bye.
Bye.